Dear participant, good afternoon and welcome to you all to this 4-day session. The main objective of this training is to spread awareness and to enhance the expertise of industrial stakeholder in member state of SARC. And the training is mainly focusing on industrial motor system, energy efficiency and saving potential, motor system standardization, remote digital live training, demonstration of MEPC online calculation, industrial IoT solution, smart meter application, industrial communication protocol, etc. So today we are starting the 4-day session, and Mr. Hugo is there to take all the session, and he will be using some software platform and giving presentation on digitization of motor and energy system. So I have introduced him in the first day, so let me repeat his introduction again. Mr. Hugo started his career by working for China Standard Certification Center in the field of energy efficient product certification, standardization, labeling, and now is a technical manager in top 10 China. He has conducted many studies on energy efficient product used in household, office, and in vehicles. He introduced top 10 motor from Switzerland to China, and he has been working and providing training on POM Demonstrator, which is software developed by Swiss Topomotor. His area of interest covers testing, standardization, and market research. So with this, Mr. Hugo, you may go with the presentation, please.
Okay, thank you, Tula. Thank you for your introduction. Okay, I think right now it's my turn to show my desktop. Can you see my screen?
Yeah.
Can you?
Yeah.
Okay. So I will start my introduction. So good afternoon, everyone. So today is my solo session for the whole day. I think it's also a tough task for me because I have a lot to share with you, and also
Mr. Hugo, you can make your screen bigger. You can make your screen bigger.
So, I understand what you're talking, but I think that's enough because I already resized everything, because I will switch between the presentation and also some other demonstration. I don't want to just only in presentation mode. Okay, so no problem.
That will be okay.
Acceptable. So because today I'm not just going to present something, but I'm going to show you something, and I'm going to demonstrate something to you. And I suggest you to follow the links we provide today, and also by SARC Energy Center. And also I hope that you can practice this with me. Of course, if you have any questions, you can ask me again. Like I already introduced myself 2 days ago, I have 3 roles: researcher, programmer, coordinator. So today I will have a role like programmer, because I already introduced that I can programming in C, C++, C#, and also on the series other programming languages. Why? Because I didn't study computing technology actually, but I think the information technology, especially the computing technologies, will change our world. When I studied in universities, then I studied by my own about programming, but finally I did the research of energy efficiency. But I also did a lot of programming study in last years, keep my studying, and I did a lot of programming for embedded service and systems, and also I developed my own IoT solution. Okay, can you hear me? Hello?
Yeah, we can hear you. Please go ahead.
Because I was reminded by software that I probably got some network problem. I think it's okay. And then
your voice is very clear than before. You are
Okay,
very clear today.
also we have to do some web programming, and we'll show you later today, and also some web crawling. Of course, I'm the organizer and also the coordinator of the training program, and I'm happy to coordinate in future a lot of other international projects. And let's start. This is what I'm going to introduce today or share today. The first one is I start with some questions. Why is digitalization needed? Why? Because our topic, our theme of this week's training is about digitalization of motor system. But first we have to solve the problem. Why do we need digitalization? And second question is, what is digitalization? I think you already have a lot of information about this topic. I will share my insights about what the digitalization means. And I think I will show you the best point could be the how to do digitalization according to my experience, because we introduced the space pump demonstrator, we invented our own digitalization solution, and then I already show you this Tuesday. And today I'm going to disclose some technologies, some sensors, something else to you for you, and finally we have some cases that I already did in my life, in my work, in my project. The first one is environmental monitoring. That's a very useful case for my decoration several years ago. Second is electricity monitoring. That's what I did for the manufacturers and for the buildings and for the other energy systems before. Of course, we have the smart pump demonstrator system. I will introduce in detail, and also maybe one more case called smart watering. I don't know whether I have time, but I think I will introduce a theory and also show the sensor plus the actuator, and also have a lot of other cases I cannot share today, but hopefully we can share you with later in some other opportunities. The first question is, why digitalization? Of course, we have a lot of benefits from the digitalization process. The first one is it can reduce our costs because it can provide data for our management. We can improve our productivity. Second is we can decentralize the production. That means like what we are doing today. Previously, without the telecom communication technology, I have to fly to somewhere in Pakistan or somewhere in India or somewhere in the South Asia region to show what I've learned. And also maybe you can gather from different countries in one place to have this kind of the meeting or training. But right now it's internet, of course, also telecom communication. Of course, it's still digitalization technology development. We can use decentralized meeting. Of course, the decentralized production is visible. That means we can produce here, and also we can manage them in centralized IT, information technology. I think that's the ERP or a lot of solutions being invented. But I think what we are doing for the motor system or for the energy system would be we want to enhance the efficiency and our productivity. I think the expert from ABB, 2 days ago already showed you how the manufacturers or the equipment suppliers solution for the productivity or their digitalization solution. And fourth is because it creates new business opportunities. Right now in China, the coding, a programmer, is a very hot topic. It creates a lot of the interesting jobs. Wait for a moment. Okay, so I'm back. Programmers in China and US create a lot of the business opportunities, create a lot of jobs. I think it also creates jobs in India. I don't know the other countries in South Asia, but I think information technology digitalization creates a lot of opportunities for business and also for jobs. And also it accelerates the direction to mind trend. That means sometimes the digitalization guide us to something new, especially in the entertainment industries. And also it fosters competitive advantages. It will give us some, competitive advantage in efficiency. I will because, sorry for that, because I have two energetic kids. I think that sometimes have to to ask them to support my work, and also we can stimulate innovations against disruption, and also we can use international, we can boost the internal coalition and improve the use of data capacity, and for the rest to bring new talents and interest. I think that's the benefits we brought. A lot of people know that. I don't want to repeat in detail. Also, you can check the, from internet. You can find a lot of similar information like this. And this is a graph of the benefits of what I mentioned before. I don't want to repeat again. And from my understanding, the digitalization benefits for the motor system. Of course, the first one is improve efficiency. Like Andrea, like ABB, like a lot of people already show that if we have good condition monitoring of the motor system, we can have the chance to improve the operating efficiency of the motor system and other, maybe even safety, because we can test the vibration, noise, temperature, and also even the air of the operating conditioning of the system. Second is we can perform very good energy performance audit. Previously, a lot of factories has no data except the energy bill. They don't have the specific energy monitoring of their facilities. Then with this kind of digitalization technology, energy performance audit becomes very precise and visible. Third is called a new topic, not a new topic, but a very interesting topic, predictive maintenance. By monitoring the operation time and also the vibration, the noise, even the thermal status of the system, with the support of expertise, all the AI systems, we can do some predictive maintenance before the machine was broken by the operation. We can predict that it will be broken in maybe in 1 month or in 2 weeks or some weeks. Then we can start it. We can plan the maintenance. We can stop the persisting positively, and then we can take the machine out and also do some maintenance, which can improve our productivity and also reduce the downtime of our processing line. Okay, and finally, as I mentioned, with the data, we can do some system redesign and resize to not only improve efficiency, but also to cut the demands from the system, to optimize our processing line, and also to cut energy consumption. Like Andrea mentioned yesterday, although even if the downsides of the VFD and also the motor decrease the efficiency, but it saves energy. Maybe it sounds a little paradox, but it's a truth, also it's a fact. The next question is, what is digitalization? Terms and definition. When I prepared the slides in last weeks, this is a problem also for me, a question in my mind for a long time. First, I Googled, and also I searched a lot of the papers, also maybe the web pages. I found the definition from Wikipedia or maybe other sources, and this is what I thought. The first is digitalization is a process in which the aspect of social life are reconstructed around digital communication. It's a very, very broad topic, very broad umbrella definition. Okay, so I think it's correct, but not very specific. And I found the next term called digitization. That means it's a little bit more specific. It mentioned that it's a process of converting information into digital, means computer readable format. The result is a representation of an object, image, sound, or signal by generating a series of numbers that describe discrete set of points or samples. It's a little bit, it's a bit scholar definition, but I highlighted the two terms. First one is object. Object means motor system, maybe our industrial processing line, one equipment, one device, one meter, or anything that's object. Object is a term in our life or in our in our work. Signal is most important. That means we use our meters, our sensors to to measure the object, the environment. Then we got signal. It mentioned during an analog signal. I think that's more or less correct, but in most cases, the sensors will transfer or convert this analog signal into digital signal, and also it will be used for transmission, processing, storage, and later will be presented by our technologies. So finally, I have found a term called digital transformation. It means a company adopting a digital technology. That means a company or even country or a region, deciding to take advantage of digitalization technologies. They make the decision to adopt digital technologies to support them, to improve the efficiency, to improve their productivity, and also maybe to enhance their competitiveness in their, of their entities. I think it's still general terms. Okay. The next one is how to do digitalization. The first question I want to ask is what do we want to sense? Because in our environment, in our working conditions, in everything, we have to sense the environment. Our people, we use eyes, nose, mouth, ears, to sense the world, and also use our hand to sense the world, to touch, to hand, to feel the world. That's why we can get some inputs, and also it persists by our brain, and also we can take the proper decision, and also make some action, or maybe some execution activity, and also to take, to get some effect. But for the machine and for the IoT world, it means we can sense a lot. But for our context or in our industrial process, we have to think about what we want to sense for our digitalization work. The first broad topic is environment. The environment means a lot. The first one I can see is air quality, because air quality becomes a very hot topic in last 10 years, because we can see the foggy sky, we can see the dusty sky, then we have to measure PM 2.5, that's the particles, that's the small particles, also PM 10, and also we want to measure the air pressure, because we want to know the position, and also we want to measure some pollutants like NOx or SOx, that's some chemicals hazardous chemicals in the air, and also we want to measure the ozone, because it also can make some effect of our health, and also we want to measure the CO2, because in some context, if the CO2 is too high, then to make people feel uncomfortable, and also it will cause a lot of hazards, disasters. That's the first thing. Second is water quality, because for waters we want to measure the BOD, COD. That's very professional terms for the pollutants in the water, and also turbidity. That means we want to see its cleanness of the water. Then we can check the water quality. We want to, of course, we can use the eyes to see it, but we cannot, we cannot determine with our eyes and also our smell. We cannot determine exactly how good or how bad of the water quality. And also, that's the most common thing is for our comfortable is temperature plus humidity. Temperature plus humidity creates the comfortless of a life, and later I'll show you how we measure it. Of course, we have to sense the hazardous gas. Hazardous gas means it can generate some problem for your body, like TVUC, CH2O, that's especially for decoration, I will show one very good case of this kind of hazardous gas after new decoration in my apartment several years ago. That's a very good application case for me, and I want to share this little story and also case with you. Very interesting. And also, if we want to have a agriculture industries, we have to measure the wetlands and also stability of the soil. Second is energy. So energy is the most important topic for our motor system. See, that means the first one is electricity. Electricity is everywhere, and also we want to measure electricity. We want to measure its power and its voltage, and also maybe its current, the power factor, the harmonic, and also maybe something like the balance of the three phases of the power, and also maybe the operating power, reactive power, everything we want to know about electricity, and also we want to accumulate it. Second is for the motor system, like I mentioned, motor system energy efficiency, it's about liquid system, fluid system, and also we have to measure the liquids. Liquid means water. We want to measure the quantity of the water or the velocity of the water and also the pressure of the water. If we have the same, especially the quantity and also the pressure, then we can calculate the output of the power of the hydromechanical power of the flow in the pipes. And then for the fan system and also for the air compressor system, we have to measure the airflow. That still means air quality, velocity, pressure, temperature, and also with dew points, and also a lot of good, interesting, parameters we want to measure. Of course, for industries, also for other things, we have to also measure other parameters, including the rotating speed of the motor, and also the vibration. Vibration is also quite important because if the vibration is too high, that means it has higher possibility of broken in some day. Okay, if I have the big data, we can even check the vibration changes in days or hours or months, then we can make some predictive maintenance. Vibration is most important, maybe most important parameter for the predictive maintenance. And also for some lighting, brightness, we want to turn the light on off, we have to have one input, what's the lighting brightness right now, then we decide whether we can to shade it, or maybe we can open the window, open the shade, or maybe we can turn on the lights. Finally, thermals, like we can thermal camera to check whether it's overheat with some the flare radiation. I think that's parameters that I can imagine in a sense. Of course, you are also expert in your field. You can use everything that you can see and also maybe find the parameters you want to sense. Then you can find if the parameters to be decided, then you can see where I can find the sensor. Okay. The next question is maybe not how to find a sensor. It's for for the industry world, for the automatic control world, is what do we want to control? When we connect something, we can process in our mind. We can also maybe ask strategies for external knowledge, human people thinking, and also then we can make the decision. Then finally we have to execute the action, accurate actions. And also we want to know what do we control from this kind of automation world, or maybe industrial automation world, or maybe the IoT world. The first one from answer, it's operation on and off. That means we turn the machine on, turn the machine off. We can we can control the motor by turning on, turn off by relays, by some switch cabinets, and also we can shut the power system on and off, and also we can shut the processing line on and off. That's most or the basic operation of the automation. But we need strong support to decide whether it's on and off. And second is speed. That means we want to control the processing line speed, the motor speed, and a lot of stuff. Then we want to control the voltage and current of the power system. For some motor systems, we can reach the goal of control the voltage current, the DC current actually, to control the speed. Second is we control the frequency. That means we can remotely control the frequency of the VFD. Then we have the chance to control the speed of the motor. Then we have the chance to control the speed of the processing line of our productivity. Finally, we want to control the status. The first one is valve. Valve means, of course, for mechanical valve, we cannot control the valve, but with electrical magnet valves, we can control its opening rate. Also, maybe with the actuator, we can also control the opening rate. And also, we can control the opening rate of the diameter for the fan system. And also, we can configure the system operation. That means we want to speed up, we want to slow it down, we want to turn it off by some timer, or maybe we can switch it on by some timing or some planning. I think that's what we will control. Then this is a diagram that I use to, how do we sense and control? Because I simplified the whole process by a very simplified diagram. From left side, we have sensor. And also we can have actuator. Of course, we can have sensor and actuator. That means that in the same machine or the same equipment, sensor could be like air sensor, like the water sensor, or some maybe the power sensor. And also actuator, maybe a lot of actuator, like the valve actuator, and also maybe the relay. It will be used to control the system output and also control it on and off. And also we can have sensor and actuator. Most typical sensor plus actuator is PLC and the VFD. For the arrow means information flow. For sensor, it only has information from sensor to controller or gateway. That means we can get the information from sensor, and then after controllers calculation or strategy making, then it can send the control orders to the actuator directly, or we can send the control to the sensor or the actuator directly, or we can maybe to send the information to cloud via gateway. Gateway normally means this kind of automated controller. It has the capacity to be connected to the internet, to the cloud, or remote computer. Then, because this remote computer or cloud computer controller, it has much more computing capacity. It can integrate all the information that's connected and also make a proper decision. And then the decision will transfer back to the controller or the gateway, and then it goes back to the actuator to take some actions. Actually, I use two boxes. This red box means actually it's a fiber. It's a physical layer. This dash box is a cyber layer. Actually, in the next two sessions, the first one is The first session is Modbus. Actually, it's communication protocol for this red box. This OPCU 8 I'm going to introduce tomorrow belongs to this dash box. It's different word, but it will be connected via this kind of called gateway. Gateway, that means I can call it's a cyber physical connection point. A lot of actually companies like ABB, like I mentioned, they invested a lot of resources to invent such kind of gateway, because ABB, they have one gateway to connect to the sensor. The sensor attached to the motor. The sensor send the data to the gateway wireless, of course. Then the gateway will be connected to internet, send the data to cloud. Then you have the data in the cloud. Then you can see what you can do. Okay. I defined 4 levels sensing. The level 1 sense. I think if you work in the factories, you already seen this in a lot of applications. I can call traditional methods. This is the picture from the cabinet front control panel of factories. I don't know whether it's a the switch cabinet or maybe some central controlled cabinet. You can see we have the ambient meter, the current meter, 3-phase, or maybe something to show that the current operating ambient of the system. We can read it roughly, when the when it comes to some point, you can see it, and also maybe some lighting button, some kind of button. Then you can, whether it's light, it's off. Then you can see whether it's operating or it's stopped. This is I think traditional. Everyone knows that. I think you experience too. This is the voltage meter. Then we can see what's the voltage, and maybe 300 here, and also if it's higher than 300 or 340, that means it's dangerous. Then we'll call somebody to support, and also maybe call the manager to say, I will turn the machine on and off, turn it off because the voltage is too high. It means it will create some problem. I think that's a traditional sensor or meters. The next one is a pressure meter, actually from the pump system. I think it's a pressure meter from the pump system. We can check, the engineers on site normally they will bring maybe a textbook and to check the parameters of such kind of traditional meters, and write them down every 1 hour, maybe every half day, to check the operation, also keep the maintenance record, and also to see whether it's operating in normal or maybe it's not some problem, then it can be extra support to, I think that's traditional work. Everyone knows that. But still, I can call it this level 1 sense. This is level 2 sense. We have digital meters. Previously, we can only see, from this kind of needle to check the position of this, the pointer to see the status. It's also maybe it will be interpreted by the engineers. But here they show you some very simple liquid display some with the specific data or the word or the numbers. Here maybe I don't know where it is because it's operating status, but here obviously it's a power meter. We can see the voltage, the current, the power, and also maybe the apparent power, a reactive power, a lot of parameters. We can use the buttons to change the parameter, and we can also check it. But anyway, you still have to, to read it, you have to record it manually, and also you have to think about and also to do everything manually. You cannot do this automatically, or it relies on engineers' capacity. And this is level 1 sense. Level 3 sense, we use the external digital meter because normally the equipment supplier and also maybe the system supplier to provide you some equipment or some meters that you can use for your daily operation. But if you want to get in-depth understanding of the system operation, the parameters or the meters provided by default, they're not good enough. Then you have to use some external digital meters to measure your system. This is the photo from that's I think the motor testing in factories in my city several years ago. We use the professional power meter. Go to factories, we invite we ask them to open the cabinet, and also I taught them how to install the power meter, and then we can see, we can get some results. Then we can have a little bit better understanding of system operation if we can have this kind of professional external digital meter. This is the first one. And let me show you some very in detail. This is actually the power meter. We have to measure the 3-phase power consumption. This red loop is called power loop. It's it's wrapped the 3 phases of the power system, and this is called P1, P2, and P3. And this blue clamps to the also the power word. It's used to make this red loop called current loop is used to measure the current. This blue clamp used to measure the voltage and also power factor. With it kind of, I can call it the current and the voltage, then we can have understand the power consumption of system. And here is the digital, interface of the meter. Right now we have the, some instant digital data here, and also we have some timely, periodically the consumption of the changes of the power system. And here is a photo that I trained the engineers from the factories, how to use this kind of the power meters to measure their high prioritized water system in the daily work, because also want to get better understanding of the system operation, especially for their power consumption. And this external professional digital meter, we can export the data to computer, because they have installed the they have the SD card. That we take the SD card out, and also we can use USB cable connect to the power, and also connect to our computer. We can export the data. And also export data. Then we can use some other professional analyze tools to draw the graphs. Here is a pump system operation graph. We can see that this is a pump system with operating, the power like 171 kilowatts per hour. I think, and then we can see, the system runs more or less stably. It maintains the status of 170 kilowatts. That means this is a stable, constant operating system. And then we'll check the power. Then we can calculate according to the nameplate information of the power. We can calculate the load factor, which is 78.1. 78.1 power factor. That's loading factor. Then we can estimate the operating efficiency of the motor. This is the case 1. And this is the case 2. Actually, it's an air compressor system operation. We invited, or we by chance, they first for the first half of the operation, the system is operated stably. Then they turn the machine off. That means the power, goes down to 0 from around 75 kilowatts. Then it stops for some minutes, and they turn the machine on again, and then the load maybe keeps in some places, and then it goes up to the normal. But we can see that during this kind of professional testing, we know that maybe the people in the industry know that the starting current or starting power of the motor can be higher than 5 times than nominal power. Then we can see that this short time power goes up because it's starting power. We can see that when the motor, that's why it explains when you start the power, or when you start the motor, the power consumption of the motor will increase, like bump up and then slows down. Okay, this is a photo. Maybe I will show you something, the real data, because we export the data from the power meter. Then let me show you some cases. This is a data file. I use the Fluke. This is a meter. Then it's a Fluke. The software provided by the meter supplier. Then we can check. Here is the abstract, and here is the digital table. It has a lot of table information there. Here is voltage and current, and here is statistic. I don't want to introduce this software, but I want to show you if you use extra power meter what you can get. And this is the balance of the frequency. And most important is the power. Then I use only the combined the power. This is the power. We can see that if we turn the machine from on to off, then it goes down. Quite simple, correct? And also we can check the power factor. A lot of information can be disclosed. And this may be another one. Okay, I want to close this one. No, not this one. From this graph, we can see one motor system, how it starts. When the pump system starts, the system, tries to, it jumps. It tries to, to balance. Finally, it reaches to a very stable status, operating status, called operating status. This is one case. Maybe another case is, it's a full cycle. That's a graph from my presentation, but I will show you the detailed data. And also this is the power. See, this is a screenshot from my slide, but this is real data. You can use your mouse to zoom in the data. Also, we zoom out. Look. I won't turn it on and off sometimes. See, if we zoom this out, you can see that why the power goes up and goes down. No, power factor. No, here the power suddenly goes up because the starting power, the starting current of the motor system is really high. And also this one, no, this one is not typical. I want to show a very typical of the air compressor. No, not this one. Where is constant? No, it's not this one. Because we test a lot of, okay, maybe this is air compressor. Yeah, this is no, close. Actually, this is air compressor graph. We can see that this is air compressor. When the system, the production line runs off normally, then when the system, they don't need this kind of air compressed air, then the machine goes, I don't think it goes down, then it stops, it halt a little bit. Then when the demand increase, it starts work again, then it decrease. Then it goes up, then we can see that how the air compressor system, if you record this in long time, then you can see how the air compressor system operated in the factories. Then you can take proper understanding. Then you can show also the data to the expert or the consultants. Then they will give you some professional advice how you can improve the system. I think that's the level 3 digitalization I want to share with you. And level 4 is I presented already 2 days ago. It's a real IoT oriented sense. That means we can sample, we can shoot, and we can start transmission directly. That means we have the sensors like VFD can be sensors, and also flow meters, also pressure meters, also have power meters. Then all the sensors will be connected to one data gateway. Data gateway communicates with all the sensors, actuators, and also it can be used to control the frequency of the VFD. Then the data gateway communicates to the cloud via the Wi-Fi. Of course, you can use the mobile network, use 3G GPRS, use 2G GSM, and also you can use 4G, even the 5G technologies. Then the cloud server can provide the information to some clients. They can feed the information to clients. I think this is a typical, I think, classic modern IoT technology. I think that may be the highest level of the sense level. Okay. Okay, I mentioned a lot of stuff, and here I leave empty because I'm going to show you some sensors that I've used. And let me show you. Can you see? Can you see me? Because I pilot a lot of. Where can I cannot see myself. Can you see my face?
Hello.
Hello.
Ah, Hugo. Yeah, you are visible.
Okay, so this is actually the air quality sensor. I will later introduce how I use it. Actually, this is the soil wetland sensor. We insert it into the soil, into the earth. Then we can measure the wetlands of the soil. It can be used to, for the irrigation. And this is the power meter I used to monitor the whole house. Of course, can be used for the monitor the industrial motor system power consumption. It's a smart power meter. It can be connected to the gateway, and also it can be controlled by the gateway. Yeah, and also it provides some call it Modbus communication capacity. That's why I will introduce. I will highlight this later. This is this is a wetlands, the soil earth wetlands meter, and this is a small motor with small pumps, with with two pipes. I didn't touch the pipes. This can be used to to sense the wetlands, and then it will be transferred to the cloud. Then you can remotely control, if the wetlands will be reduced to some level, then you can remotely to turn the pump on. Then it will pump the water from maybe some small tank or even from some small box and to the irrigation of the flower vessel. Okay. Let me check. This is also air quality sensor. It can be used. It also can be used to check to measure the I think could be measure the hazardous gas of the sensor. Okay. And this is a DC motor sensor. I need to unbox it. And this is ultrasonic. Can use measure the distance of your hand, of your body. Okay. Yeah, a lot of sensors. And this is actually the remote temperature sensor. You don't have to touch it because after the COVID-19 outbroken in China last year, from internet we cannot even buy this kind of called the temperature sensor of the body. You don't have to touch it. It can measure your body temperature automatically, remotely, like I think 1 meter, from 1 meter distance, you can measure it. And this is the gateway I use for the pump demonstrator. With this is a LED. It's an LED screen, and those 3 buttons, and also it has pins to communicate with external sensors. Actually, we use here. It's very simple logic. This is a gateway. This is sensor. We can use interface provided by the system, and also if we we can connect it. Then the sensor and the gateway or the controller will be connected. I think you can understand this. It's quite simple, but it still takes some time to experience it. Okay, let's see the sensors, because we have a lot of sensors. You can buy sensors from internet. I don't want to repeat this again, and I'm going to introduce some cases. Okay, this is the first case called house toxic gas monitoring. I don't want. This is the video I took several years ago. You can see that we have a small LCD panel here. You can see that it measures PM25, PM2.5, PM10, temperature, humidity, and also the TVUC, and also CH2O of my new decorated house, and also CO2. Let me tell you the background of this project. Several years ago, I bought a new house. I started decoration. At the end of decoration, one concern from my side is that at that time my son was very like he's a baby. I want to have a healthy house. Then I decided to use my technology, use my knowledge to build a solution to measure the hazardous toxic gas in the new decorated house. Then I will decide when I can move into the new house, to new apartment, to my new home. The criteria is the CH2 of the house reduced to the acceptable level, which is below 5 or 10. Then I think the house is good. Then I start to build this kind of solution. Actually, I should have seen toxic. It looks a little bit, if you are an electrician, if you like the electronic design, you understand this quite well. Let me show, okay. Use my pen. This is a sensor. I already show you, this is sensor, okay? This is sensor. For this presentation, for this training, from my laboratory, I found this several years ago. I used this is the air sensor, air quality sensor. Then it's connected to the gateway. At that time, the gateway is very, very simple. It's actually developed in board with some pins. You can connect the sensor with the pins with a cable, with this colorful cable, which is called two-pound cable. It's available on internet. And then I bought this kind of, this is a gateway. And this is a LCD screen. It's also connected to the cable via this called breadboard, this white breadboard. Okay. And then I used a kind of accessory called this storage card to store the data sample from the sensor, because maybe every minute I will read the sensor and also save the data in the file in this kind of storage card. Then I can take this card out and also export the card to my computer. Then I can analyze the data, and then I will decide whether it's good enough for me to move in. And of course, I have a small control button, which is, I think finally I decided to cancel it. This is the first version. The first version already works, but the problem is that because I don't live in that house, so maybe every week or maybe even every 2 weeks, I have to go to the house and also take the card out, export the data to my computer, then I can see whether it's good enough. That means every 2 weeks I have to go there. That means it consumes my time. Then I have the second version, the version 2. It's simplified. Sensor is still here, and also this is the gateway. And I canceled the LED board. I canceled the SD card. I removed the SD card. I removed the operation button. I added one GSM network because I plugged in with a SIM card, communication card with my LAN. Then we send the data to the cloud via this kind of GSM model. That means I don't have to go to my house to check the status of the, I don't have to check every 2 weeks. Then I can set down in my computer every time I open my computer. I can connect to my cloud server, can check the status. Then I can export the data to an analyze tool, and then I can check the house toxic gas status in my new apartment. Then I decided when I move in. So these tools help me to move in like 2 months in advance. That means I saved 2 months rent from previous house renting. That means that's a benefit from my investment. But of course, the most important is the health of the baby. Okay. A second case is, of course, pump demonstrator. The Swiss version I introduced this Tuesday that it cannot be remotely. Everyone has to go to the lab to see the figures or the numbers here in the panel. It's not easy for us to go to Switzerland, or even for the Swiss to go to Switzerland to to go to lab, and also to be trained. That means, of course, this is a good mechanism, but still it consumes a lot of energy. And then, of course, I can control the valve here by myself, of course, because I didn't come there on purposely, because I visited Switzerland for meetings, the Motor Summit meeting in 2016, and then I decided to, by chance, with lab, to experience the lab. Finally, I thought it's quite good. Then I decided to import this to China, but I have to make some innovation. I can call it IoT or smart or digital pump demonstrator. We follow the same hydraulic design, and I showed the graph this Friday. But today I'm going to show you how the sensors, how the actuators have been placed. The core part here is flow sensor for the big pump systems here. This is a flow sensor. Flow meter, actually it's a meter, flow meter. Then this is the flow meter 2. And this is flow meter 3 and 4, because I want to, to pilot different sensors or meters. I don't want just only use one metering technologies. I want to metering 2 metering technology. I want to experience 2 metering technology. That's a flow meter. In total, I think we bought 4 meters, because meters actually is quite expensive. So we cannot afford to install every small pump, every pump with 1 meter. We have 4 meters, flow meters. Here is a cabinet box. We install 4 VFDs, ABB VFDs. Okay. We have 4 ABB VFDs. Then this is control panel. When we open this, we can connect it. Then the ABB VFDs also be exported. And also we have 10 pressure meter sensor here. 5 before and 5. For each pump system, we need 1 pressure meter before and after the pump. Then in total, 5 pumps with 10 pressure meter, because the pressure meter, the price is acceptable, and also, but the accuracy of the pressure meter is not very good. In total, we have 90 meters of sensors. They are all gathered with this kind of blue signal table to a Modbus hub. This Modbus hub is connected by also cable, like mentioned, to this small gateway. It's a small gateway, actually. The real high technology stuff is very small, but it has capacity to be connected to Wi-Fi. And then I have the Wi-Fi in this laboratory. Then we send the data to the cloud via the Wi-Fi. And this is, the physical layout of our smart pump demonstrator design. And this is a detailed graph of this kind of gateway. This is a gateway. Of course, we printed out some sample digital information on the screen. Here is a big pump system. We see it's on sample. Yes, the frequency is 44. And also we have the speed, and also voltage, current, power, flow, pressure before, and pressure after. That's most important parameters of 1 pump system. Of course, we can switch this by push the buttons. Let's put A, B, and C. Then this is a RS285 hub. It's a hub to connect to all sensors. and then it has one external cable to be connected to this gateway. Then that's the end. That's a physical level. This gateway will transfer all the physical level signals and those information via Wi-Fi network, cloud. Then the cloud server, this is cloud server screenshot, will take the data. Actually, this is encrypted data, so some numbers, meaning you cannot read it. But here it's a decrypted sized information. And also we have interface to show, and even for the server to see the operating status. But I finally canceled this because it consumes too much resources. We don't have to, to use kind of UI design for the OPC server. I think that's in-depth understanding of our smart competency demonstrator design. Yep. Maybe let me see. Okay, that's the case 3. We touched also the electricity monitoring. This is smart meter I used. Of course, you can find a lot of similar smart meters on the market. This is a current loop. Let me show you. Can you turn my video on? I can turn the video on by myself. Okay. So can you see me? Hello? Can you see my screen? Or see my face on the sensor?
You and that sensor, yeah.
Okay. So let me find the cable first. Actually, this is a current loop with root loops. We install this, and also this is a cable, the power cable. From any cable system, we can put them, we can go through it or install through it. Then we can measure the three phase. Here is a sensor. Here is a sensor. Then it's connected, the phase A, phase B, and phase C, and it's connected to this power sensor, power meter. Then we have this kind of voltage sensor interface here. That is voltage for A, B, C, and this is a power supply for the sensor, because the sensor needs to be powered by 24 voltage DC current. And this is a Modbus A and Modbus B are 485A, 485B. I will introduce this later, how we do use Modbus. Then our, our gateway will be connected via this AB, the Modbus, to this gateway. Then you can use the gateway to sample data, send the data to cloud. I think the logic is similar or even the same with the pump demonstrator, and everything is the same. But I'm going to show you the result. I think I invite you to open the link. The tool I sent you early today. And I'm going to also open the can I see it? Okay, because I did this English version for this training for you. Okay, can I say that? You can see right now lively about my house power consumption. And here is real-time status. This is the power meter installed in the total cabinet of my house. You can see that the current power of my whole family electricity is around 600 watt. The power factor is 0.9, it's pretty high. And this is sampling time. That means Beijing time is about 3 hours in advance. Pakistan time, that means right now it's about 3 o'clock, 8 in your time. In every 10 seconds, in every 10 seconds, this data will be uploaded to my cloud. Then I can monitor monitor real-time status of my house. Second is air quality, because also I installed the one air sensor to check the air quality of my house for the daily. And here we have the PM 2.5 right now. It's about 68, 70. It's not very good. So the normal case is for 30 or 20. It's good. For the PM10, 85. And also here the temperature of my. It's not far. It's about 10 meters from my desk. It's about 14.1 degrees Celsius, and also humidity is about 58. That's why I have to wear very heavy clothes of very heavy jacket to protect myself. This is decent power. And then the data has been stored into the database. Then I can use the historical state to check this information. And this is the default is 12 hours, but I can click here. I can have enough 24 hours of my house power consumption. And this is statistic. Here, I can see that in last 24 hours, my whole family consumes about 8.8 kilowatt hours. The average power is about 385 watts, and also almost 24 hours. How many minutes? About 1,400 minutes. And also I can change the time to choose anything that I want. I want to see 2 days result. Wait for a minute. Then I can see that, can use analyze. Then can see that in 2 days I analyzed, we consumed 18 kilowatt hours in statistic. But I want to show you the 24 hours. I don't want to show the power factor, but I think that power discretes some problem or some cases. Here I can show you. Here is we use yesterday we use this oven, electric oven, to do some barbecue. And then I can see that that's a washing machine. No, not washing machine. The dishwasher turns on. That means for some hours. And here is the basic load. This is for refrigerator, and this is basic load even when I sleep. That means quite deep in the night. And then every morning, my mother will use the water kettle to prepare the hot water for the morning session. For the morning, then when the morning goes up, we turn on the light, we turn on the appliances. We start to use this kind of take electricity. Then maybe TV goes up, and also maybe refrigerator, and also some added devices will go up. I think this is one example. When we have the data, then we can have the a profile of the energy consumption. This is a profile of my family. I did a lot of public education, but I cannot explain how your appliances is consumed in your life. With this kind of support, after maybe 1 year, I can analyze my energy consumption in my house, and then I can use this kind of graph to educate the public how you can save energy in your house. Without such kind of evidence, it's not easy to explain to them. But also in our digitalization of the industrial world, we still need such kind of data. I think that, like ABB expert mentioned yesterday, and there are a lot of other cases, the data will be used to draw the graphs, for the profiles, and also some statistics that you can use for your analysis. And here is another good example. This temperature and also humidity changed in my house. Here I want to move the time to maybe longer. I can analyze. So it takes some time because I can turn the humidity off. Then we can see that from early October, the temperature in my house is about 27 degrees. Then it goes down. In general case, it goes down. Then maybe at the end of October, it goes up and then goes down. Finally, it goes down until now it's only 14 degrees. I will maybe we can even. I think that's here at maximum because I started this monitoring from November. With that kind of data, then you can do whatever with analyze, or you can do some, optimization of the energy system by your own. Let me also show you something different because I want to show you a little bit in depth how the data has been stored. The data has been stored in the database, in my database. So not smartphone. Let me show you the power status. This is table. This is data table that I use to store its data. Here we can save the voltage because I didn't show the voltage in the website, but still we can see. Yes, I store the voltage A because in the whole family it's only one phase. We don't have phase 2, phase 3 because without 3 phases, current, active power, reactive power, apparent power, power factor, and also from which data gateway comes, and also sample time. And here is sample time because it's CET time. In China could be minus by 8 hours. The last one consumes in 1 minute ago. That's the data. Then I also export the data for Excel, for some, we can provide the interface for even we can provide OPIs for other programs or analyze tools to, to help us to optimize our system. Okay, this is electricity monitoring, and also the smart socket. A very interesting stuff I would like to show you. This is the socket. Can you see me? The power goes in from this side. Then it can be connected to any appliances. The maximum power is 2.2 kilowatts. This is a gateway. Actually, we don't have to connect this socket to an external gateway, but this gateway is attached to this socket. It's quite small, like a nail, only nail size. See, nail size. It can be attached to this socket. Actually, it's from the same producer. I do the programming of the software. Then it uses Wi-Fi. This is the gateway, and this is actually a sensor plus actuator. Even it's quite small. Okay. The case is I'm going to tell you from the browser. You can see that we have the smart socket real time. Actually, I can show you that this is from refrigerator, and this is from the TV. Right now it's 120 watts. Normally it's 0 or at most 3 watts. Right now my kids are watching TV, so the consumption of my TV is about 120. So when the power shows up like 120, we can see that my kids turn the TV on. I can remotely to see how my TV was turned on and off. It's room air conditioner. I don't use it in my living house. And this is for the network storage server because I built on my own the data storage server for my private cloud. That's a 4 socket I'm using in my house. And here we can find the statistic. This is a statistic of the refrigerator. If I want in 24 hours, I can see that in 24 hours, my refrigerator consumes like 0.76 kilowatt. And because temperature is quite low, let me show you one day in August. 26 to 27. If we analyze difference, you can see that in August, because of the high temperature of the high ambient temperature, the same time, 24 hours, the refrigerator consumes doubled of the electricity. And also from the energy label, the nominal energy consumption of my refrigerator is about 0.8 kilowatts. That means maybe my refrigerator has too much food to store. So that means I have to improve it. Second one is the TV. The most interesting stuff. In the last 24 hours, I can see when from today, that means from this morning, 10:15, my kids turn the TV on and watch it for some 40 minutes. Switch off, switch on again. Short time watching, and then until the end, until the whole afternoon in like 2:30, 2:20, 4:20 p.m. They turn on the TV until now. They watch the TV, and I think I have to take care of them after during the break. I will remind them that you have to, switch the TV off. They watch too long time. It's quite interesting. It's a very interesting case, but still, it's the technology. The IoT technology can be used for our industrial IoT. And here, just I want to repeat again. Finally, I want to see the smart watering. I already show you I didn't have some cases, but it's a very good example how to, sensor plus actuator. It's still, connected. The same thing. Oh, okay, I will turn the video on. You can see, I can connect the controller or gateway, and also I can control and also sense by the sensor. Then we can, we can control it. That's simple, but everything relates to IoT or digitalization can be used. Okay, but the last one I want to say, I did all the work how to start. I don't know whether you heard about this kind of platform called Arduino before or not. I suggest you to open the link, start to experience it. I will send this to Tula. Then Tula can share with all you. You can go to this website. Arduino is an open electrical design platform. It's free. It's open source. You can find a lot of good examples, good projects, some source codes. You can also be guided how to buy the sensors, how to buy the MCUs, how to to program by yourself. I think that's also my starting point. Because we don't have enough time today, but I think I recommend you. You can even see that here. This guy, they use the same LED screen with me to measure temperature and humidity, but I'm afraid the data is wrong because temperature cannot be so high, or they are using the Kelvin system, not the Celsius system. Okay, but at last point I want to mention there are also disadvantages of the digitalization, because if we want to, the digitalization will cause some extra development and deployment costs. Actually, the programming of the programs is not cheap. You have to invest first. Second, it will generate some extra maintenance costs, because in a lot of cases, the digitalization equipment and electronics is not as robust, also maybe as tough as some mechanical stuff. We have to take care of them carefully. That means you have some extra maintenance costs. And of course, you need to training, because engineers, I'm afraid that not all engineers can have capacity to use and also to to manipulate it. So they need to be trained, or maybe new engineers will be introduced how to use and also how to make extra benefits of the system. Finally, maybe also like the ABB expert mentioned this Tuesday, if we have the data, but how to take or extract the knowledge from the data to support us to make the correct decision or strategy. That's the key, and also that's a problem for a lot of industrial IoT or digitalization systems. A lot of data has been stored, has been sampled, has been stored, but nobody knows how to make full use of it. So that's also even also a problem for me. And I heard that a lot of people think about use AI system or maybe some expert system, but still, when we get the data, we draw the graph, and we have to still use our expertise from the people, to take the right or the correct decisions to, to make the final decision and also to take the action. But can we do some automatically good stuff? I don't know, but I think still an open question for all of you. I think this is the end of my first session. I'm open to have questions. Okay.
Thank you very much, Mr. Hugo, for your presentation. And you displayed many sensors and that house proxying gas monitoring system and electricity monitoring in house. That was very interesting.
So you know, people like you I have no privacy at all. So you all can have access to, you can monitor the my house energy consumption from Pakistan, from India, from all over the world if you have the address. Of course, in later, I'm open this. I don't want to create some extra problem, but later I will put some access or authorization. Today, just link for you to show you. Okay.
Mr. Hugo, can you see some question in chat box? Maybe you may find some.
Okay, what's the price of this smart meter? Like the price of smart in China could be like 1,000 RMB. And also you can find some solutions online. I think if you get used to Arduino, you will start to search smart meters by your own, then you can buy it online. I don't know whether it's available in South Asia region, but in China, we can buy online. Everything I bought online. So I think it's quality is quite good. And also you have to, the currency capacity of the currency capacity of the loop has to be, specified during your ordering. So yeah, I think it's not very expensive. The expensive thing is from the software.
Yeah, Mr. Hugo.
Okay.
Yeah. So you talk about this air quality sensor, na? So how is strict this Chinese government to monitor this air quality, like emission from vehicle? So
can you type in the chat box?
Yeah, okay.
I didn't have the text.
Yeah, I have sent you. Maybe
How strict Chinese government is to measure? So that is Chinese government have their own monitoring system because they have they deployed the air quality sensors in the cities in some key points. Then they publish the quality. Everyone right now with a cell phone, you can take, for example, I'm going to show. And in my cell phone, I can check air quality on my community real time. So it's about metering system. It's It's not about the quality of. They have their own metering systems. How can how can we get home-based meter device in our use and home? I bought from internet from China, so if you want, I think we can work on this topic. You also want this in your home? Send me mail.
We have any question more? No. So, Mr. Ugo, so you want to take a short break or you want to continue?
I think I need a break. Maybe I will be back, I think, in 15 minutes. About
15.
3:45, a quarter to 4. Okay?
Uh-huh. Okay, okay.
Okay,
Okay.
I need some food and also some break. Okay? See you later.
Okay, dear participant, we'll meet after 15-minute break. Thank you.
Hello, Tula. I'm back. Wait.
Audience with the hand. Audience. Yeah, Mr. Ugo. Yeah, hello.
Hello.
Yeah, Mr. Ugo, please, you may start.
Again. Can you see me? Can you see my screen?
Yeah. We can see.
Okay, so before my second session, maybe I can give you more introduction of the Arduino. And when you download Arduino in your computer, you can install the software, you can open software. Maybe I think it's quite good. It's for free. It's downloadable for everyone. Here is, of course, this is Chinese menu, and you can. The most important, have a lot of examples. You can have very basic examples from the, how to, this one is how to read analog information from the MCU. It's quite simple. Few lines of code, then you can have capacity, to start it. But also, of course, you need some background of programming, or you have the enthusiasm to learn programs. And because I've started for years, and I feel it's quite, quite good. You can see have sensors, displays, frames, USBs. You can also download a lot of other examples from internet or from different board developer. Then I think it's very good for the start. I think I recommend you, if you're interested, to start from the Arduino as first step for your work and also for your future work. Okay, so let me start. And the second session I'm going to introduce is called Industrial Communication Protocol. One, Modbus. Because from my point of view, that's why I also designed this training schedule. The communication protocol is the most important to understand if you want to really to do some digitalization. I think there are a lot of trainings and also the speeches to introduce you the benefits, and also maybe the architecturing, and also maybe designing, and also maybe some theoretical graphs of the digitalization. I introduced already in the previous session or the previous slot. But right now, I will bring you into some detailed, or maybe very specific information about the industrial communication protocol. The first one is called Modbus, and also the simple file I want to repeat again. And this is, I'm going to introduce the first. We have to understand how machine communicate with machine. It's called machine-to-machine communication, how and why. And the second is we call physical layer communications, because physical layer means we want to control the device. We want my MCU, or I want my controller, I want my gateway to communicate with VFD, with the actuator, with sensor, and it's connected via the cable, like the cable I present before. It's via the cable. That's what's called physical layer communications. Okay. Then when you communicate with the physical layer, you have to choose a lot of communication protocols. Even you can use analog interpretation, and also maybe some other ways. But I choose to introduce Modbus. I'll explain why I think Modbus is quite important, and also why. And the second is, what is Modbus? I will give you some facts of Modbus, and then I will show you some cases and practices, because it's not easy to find some Modbus. On case, I make a simulator by MCU, and then I will show you how to connect the Modbus device, because normally the Modbus device is industrial device I'm at home. I don't have such kind of Modbus device except this kind, except this. This is real Modbus, but I will use simulator, simulate, and also use some external software, and also maybe use MCU, how to show you how to communicate with each other. It's very in detail. I hope you, even you don't know, if you don't have background, but I think it's worth to listen for a while. And how, that's not a communication. That's the title I mentioned is how machines to talk with each other. This graph I showed already in the previous slides or the previous presentation. But for this session, I'm going to introduce something beside the physical layer. That means physical layer communication protocol. For the next, for the cyber, that means cyber layer means the information has been sent to the cloud or maybe to the upper machine via Wi-Fi, even via Ethernet, and also maybe by some cables, and also maybe by some mobile network like GPS, GSM, or maybe 4G, 5G, and also that's called cyber layer. I think that means I highlight the importance of gateway, okay? And right now I'm going to introduce something about the communication below or in the physical layer. It's connected by cables. Still for the cables, we have a lot of cables. We have cables here at maybe communication distance about only 50 centimeters. But still we have some, cables that can communicate by 1,000 meters. Maybe I can. Physical communications, where you normally transfer the information first with analog signals. First, we use voltage. The voltage difference between plus minus 5 volts or minus plus 10 volts. We measure the voltage of input and also use some linear calculation to get if we know the range of the meter of the signal, then we can calculate the digitalized word. Let me also show you one example for Arduino. It's very simple. Let me show you one example. Digital basic analog input. For real code, it's quite simple. They call analog read. Then they can read the information from some pins, they call it pin. Then they can have the sensor value. Then they can write the value to LED to turn it on or turn it off. Very simple. Okay. Also current in a lot of industrial equipment, especially for meters, they use the 4 to 20 milliampere to amber MA, I call it simply, or MA to transfer the information of the meter of the main parameter, like the flow, like the pressure, or like some other parameters. And second, we have the analog signals. Then we have digital signals. We have HART protocol. It uses analog cable to transfer some digital label. It's quite popular for some instruments. I know that if you get close to some maybe instrument, especially the measuring instrument, the HART protocol is very popular. Maybe I have to use the capitalized HART protocol. Of course, we have the RS-232. That's quite usual. I think the most important will be the RS-485. This is very important. I will introduce the advantage of this digital line well, and also RS-422, and also have CAN mainly used for the, you can see that a lot of car communications, the car devices communications CAN. And also I2C. I2C is also very popular for some industries and also for some equipment inside. Okay, a lot of communication protocols of the physical layer, but why I choose Modbus? Because Modbus is published quite early. Actually, Modbus is published and also It's born into the world in 1979 by Modicon. Right now, it's part of the Schneider Electric, and it's open and free. That means when we know the Modbus communication specification with the machine, we can communicate with it without any problem. Of course, the precondition is that we have to connect to the device, the machine. And third is the mainstream industry devices support Modbus, because I can see that the Modbus is now become the general international standard for device to device. You can find, I don't know whether you know the industry equipment a lot. You can see from the manuals that I will show you, and also the interfaces of Modbus communication everywhere, almost everywhere. It becomes in fact international standard for a device-to-device communication. And this is, I can say all VFDs, like Andrea mentioned, VFDs, variable frequency device or frequency converter support Modbus. This is one Modbus. This is one control board of ABB ACS 550 hardware board. It has a lot of interface for for analog in, analog out, digital in, digital out, and the controller for some, you can say a lot of pins around, but still you can find this is called RS485. That means for Modbus serial communication for embedded field protocol. You can connect your controller, our controller, to the Modbus interface of this board. Then you can control it. Then you can read information from it. And this is a technical manual from this ACS 550. And from this parameter configuration table, you can see this is the address. The first one, the first column is the address. If you know the address, then you can rate the speed of the VFD of the motor, and also you can have output frequency of the VFD. You can rate the current, the torque, the power, and also the DC bus voltage. A lot of parameters that you can imagine or can be provided by the device. Let me open this protocol. It has 326 pages. One way we check is we search this document with the keyword Modbus. See that we have 95 such results. That means Modbus is everywhere. See, let me also show you the parameter table. Let me find the table content first. Hence the drive, basic control, the parameter table. Okay. Parameter list. From this list, you can see how you can read and control from this. So maybe the beauty or the advantage of Modbus, that means if you have the manual of the device, it will describe the specification, how you can connect the device. And then it will tell you the address of the parameters, and also it tells you how to control the device by the specification manual. Then you can control the device if you have capacity to develop your own controller or your own gateway. Actually, I read this, ABB VFD user manual to connect to it, configure it, and also connect it with configuration, and also use gateway to get the voltage, the current, the power, and also frequency of the VFD. That I already show you in the digitalization of the power demonstrator. Actually, I just follow the instruction from the manual of the equipment. We don't have to ask someone else. Then you can do the control. I think that's the beauty of the Modbus, because it's simple, free, and open. But the precondition, that means you have to connect it with cable. It's not wireless, it's cable, okay? A second is all PLCs. PLC I don't want to highlight because program logic controller support Modbus. Actually, the Modbus is invented for the communication between PLC. That means the sentence is Modbus is a data communications protocol originally published by Midcom, now Strider Electric, in 1979 for use with its program controllers. The ABB PLCs, the ABB PLCs, the Siemens S7 PLCs, they all support Modbus. Of course, they have a heavy and also very heavy book to describe how to connect it. I think it's also beyond my introduction today, and also I didn't study PLCs carefully because I'm not industrial automatic expert, or I don't invest time on it. But still, that means you have a capacity to connect to the PLC. Then, if you can control the PLC, then you can buy the PLC. You can control even the whole process line. You can control the whole production line. Then, when you finish your role of controlling. And the smart meters support Modbus. The smart meters I mentioned, maybe I can open it. Slide in 53. I use this is a meter. I take a close of the meter. Then I remove the red cover. Then I can find some interface that I can connect with meter. The LN is power supply. The 485A and 485B actually is interface for Modbus connection. And of course, we have some other connection you can follow the instruction from, but most of the cases, I just use this AB 485A and 485B to connect to the meter. Then I can get information from the meter. Okay. Other cases, because this is all the cases that I use. This actually this is a central air conditioner control board. It's from my queen. From this control board, you can see this A in, B in, APC, BPC with instruction of the guidebook of the user manual, and also you can control the the air conditioner. You can turn it on, turn it off. You can change the the water chiller temperature, or maybe the outside temperature. You can do some configuration, and also you can get some operation information from the system by communication with Modbus. And here is okay, again the power meter. It has maybe I don't know whether I can say that here. The first two is 485A positive. That's plus. That means plus means positive. And also the 485B negative. That means a connection to the device. Then we can take the data and go control it by it. What is Modbus? Maybe I don't know about the background, but the concept of bus is, the CPU or one, the CPU or one MCU or one chip has limited pins. Normally, I think 15 to 20 pins. So that means if one pin is connected with one equipment, that means the maximum number of the equipment attached to the to the MCU is quite limited. But with the information bus lane, I think our VFDs 1, VFD 2, our flow meter 2, our air sensor, and also power meter, they are all connected like a common use information bus lane. Every device, every control device with meters, VFDs, actuators has been given one address. It's like a phone number. If you want to send information to VFD, then you can see I sent one message to VFD with address, with the functions I'm going to use, and also the message to him. then only the VFD1 can get and react to the order from the slave or the controller gateway. So it's like common use bus lane. I think this is quite modern technology used for all computing technologies. You can see from our even computer, we have some bus, some data bus or some bus. And also for industries, we have a lot of bus, motor bus, field bus, and also profit bus. But motor bus is, I think, the original of such kind of industrial communication protocol. Then that means we can connect it a lot of devices, including sensors, controllers, actuators, into one pin area to this. I think also you can choose that maybe here. Then the motor bus, this is hub. Different devices, they are all connected to this hub. A to A, A to A, A to A, A to A, A, then B to B, B to B, B to B. Then with one output, then the controller can access to it. Okay, that's the same thing. So I just make this for conceptual explanation. So what is Modbus? So actually it is an open messaging protocol between the master, slave, one master, multi-slave devices. Actually, every time the request initiates from the master, from the controller, from the gateway, the request message from the master sent to the slaves via the bus lane, and then response can be returned to the master after some milliseconds or after some delay, depends on the implementation of the such kind of devices. And they can have one master can be connected with maximum 247 slaves. That means one master can be connected with a lot of slave devices. That means the controller can control a lot of devices in one time, but 247 is ideal or theoretical number, but actually 30 to 50 is the maximum, because also the delay of the operation cannot be accepted if too many devices has been touched to one master. But I think 20 to 30 is acceptable. Actually, our pump demonstrator has been attached with 20. That means the time delay for the sampling could be 2 seconds. If we can touch only to one device, that means time difference interval could be like 50 milliseconds. Yep. Actually, Modbus, protocol defines standard message structure. I will show you the standard message structure later, and also practice it. So don't worry. And actually, it is an independent protocol of the underlying physical layer. It can be transferred to via the RS-222, RS-232, and also RS-485. Actually, this, I want to highlight this, is the most widely applied underlying physical transmission layer. And also it has two models I want to explain in detail. RTU means everything has been sent in raw bytes, 7, 8, 10 bytes. And ANSI code means it was in black characters. Actually, in most cases, we will use RTU because it has high efficiency, has more simple communication protocol. Okay. I mentioned before the RS-485 is the most widely applied Modbus physical layer implementation. But why? Because it has a lot of advanced features. Equipment. Because first, it's widely already accepted by industries. As I've seen that if you see that everything is with AB, that means it supports 485. Because it's easy to connect, it has only 2 ports. The R232 has 9 pins, 9 number pins, and for R22 it has, for R485 it has only 2 pins, only A plus B A connects with A, B connects with B, then networking is quite easy. Second is reliable, and also it has very stable communication. So if it's connected and it's correctly connected, communication is very reliable. The fourth one would be that it has long distance communication. The R232 has maybe meters max, 1 to 2 meters, or maybe several meters. That's the maximum. But for the RS485, you can communicate. The longest to be more than 1,000 meters. That means your device can be 1,000 meters away, and also the controller could be some 1,000 meters away. That means you can have one buildings with all sensors distributed in the sensors. At old age, your controller could be in one control room. Okay, I think that's advantage. Also, it's quite advantage. And one RS485 bus line can be connected with 32 receivers. That's not the idea of 247, but 32 is still acceptable. It's still good. So it has very high communication speed, maximum to 10 megabytes per second. So the communication speed is quite good, but actually, because of the features of the Modbus, actually it's only some bytes, like 100 bytes to be a good long message. So yeah, so I think that's good, but it's not the strongest point, because other communication protocols can have even higher communication, can have higher communication speed. Okay, then let's go to the detail of the Modbus. So why I can say it's simple, because it has very, very, very simple functions code. It has, let's see most common used functions in code. The function code here, like hex number 1, 2, 3, 4, 5, 6, 15, 16. For each code, it has different meanings. The code 1 is read coil status, means read the on-off of the operating status of the machine. Second is read input status, some maybe discrete information. This is not very important. I will not touch again. And 3 means read holding registers, because the device has a lot of registers. They will set registers for you to read, and also you can set the registers to control the device. And 4 is read input registers. And a lot of people will be confused about the holding register and input register. I think the difference between holding and input is holding, you can read and write. That means you can read, you can control. But for the input, you can only read, you cannot write. That means you cannot control by input. But a lot of devices support both holding and input. Reading means you can read the status of the system by reading code. And also, you can operate by write them. Write single coil, can send the coil. If you can send the coil, means you can turn it on and off. You can normally, if you set coil 1, that means you want to turn the machine on. If you set the value to 0, that means you turn the machine off. I will demonstrate this later. Okay, and also you can write single registers. That means you can put some very specific value. If I want to send the temperature controller with some temperature like 35, then you can write 35 in the register if indicated by the manual. That means you can send each time you set 1. Of course, if you want to do some multiple operation, you can write multiple coils and also write multiple registers, which is not very popular, but it's still quite practical if you want to do some multiple control. But currently, even for me, I didn't touch this for this, because normally I would use to write single coil and write single register. Okay. Actually, even for people that don't study the have computer background, they can understand the message frame on Modbus quite easily. This is a Modbus message frame. That means it reads input register request. It has only totally 8 bytes. This is data byte index, like one array. You know, this is RTU data format. It's in hex mode. Hex. The first one is, the first byte is slave address. That means I want this message format that I mentioned. This is BFD has slave address 1. That means I want send one message to slave 1. For the rest, if even you got the message, you can omit, you can ignore it. It's only for the just like a phone call. I just send this message to the slave address with address 1. It's indicated. Then it's a function code. The function code I describe here. 4 means I want to read input registers. Okay. Then I want to read the starting address. Those two for the starting address high, low. That means I want to read the room number. This is for I want the room numbers, and then I want to read how many registers value. Means 2 means I want to read 2 values. Finally, the last 2 bytes means the error check. I don't think you can understand this quite well, but it's used to verify that the information you received is correct. It's to do the sound check. So it's a little bit technical. I don't want to mention again. But for the first 6 bytes, it means I want to send this message. I want to send the reading request to slave address 1. For the rest, ignore it. I want to read, and also I want to read the starting address with 0, and also I want 2 register value. Then I can have the response. After when you send it, maybe in some millisecond, the Modbus, the slave address, the slave device will receive it, and then it will return the response. Return response here is also means this is a message from 1. That means that's from my message. Second, it's also 4 the same with request, always the same. And also it returns 4 data bytes. This is the real value. The first register has the value 6. That means it doesn't matter. So you have to mutual definition. What 6 means? 6 means maybe degree or maybe some level, so maybe something like this. That depends on the Modbus specification or how the device defines the data. And also we have the second data is 5, number 5, and for the rest will be the checksum. And then when the master send out the request, and then it gets the response from the slave, then you can get the status of the slave. Then we finish the operation of the reading of input register. This is one inputting register. And also right now I'm going to introduce how to write single coil request. It's the same. Here I want to send write coil address to slave address 11. That means only the 11 device can take actions of such kind of request. Function code is 5. Here 5 means what? 5 means write single coil. I want control one coil value. That means I want to take some actions. And this is the coil address. AC in hex mode could be maybe 100. Okay. Then that means it will check the address of the coil. FF00 means to set the coil on, means turn the machine on. If it's 00 means I won't turn the machine off. That's a definition, and that's the definition of the protocol. So it's fixed. If we want to write single coil of the device, FF means turn it on. 0, 0 means turn off. The last one always 0. That means I want turn the slave 11 with such address. Different address means different meaning. You can turn it on or can turn some subsystem on with on or off. Then the master will send the message to the slaves. Then it will see. This is return a message from the right single coil response. This is from the address 11. Code is right single coil, and this is the address. And if it operates successfully, it will say FF, means I already turned on, or it's already turned on. The status, it will actually, the right single coil, the request, and also the response, the message will be totally the same. It will be totally the same. That means we can finish the operation, control the coil, okay? I will take another example, also maybe right single holding register request. It's the same. I want to say address 11. This is a function code 6. I want to, write the holding register address 1, and I want to set the value like 3. Then the slave device takes the message 11. Only 11 will take actions. When they take the action, if they got the success, they will return this message 11, the function code, address, and also the value 3. If they successfully write the value or we set the configuration, it takes some time, and then it will return this message to the master. Then the master can, okay, you get you already did the operation. Then I confirm that you write holding register, you perform some performance. Then I believe that in the new status, then you finish the conversation. Then the finished operation. Then maybe the controller will return this message back to higher controller or even to cloud. Okay. Right now I'm going to practice it. Okay, so I prepared something. Take some time to. Not easy. It's totally mess. Can you see me? Hello? Tula, can you see me? Camera?
Yeah, we can see you.
Okay. Actually, as I mentioned, I cannot bring you because I cannot show you the real industrial equipment because I'm home. This is actually a simulator. I did some programming with Arduino. It forms like a slave address. It can be controlled. If I write some coil, it will be, the LED inside will be turned on. I will show you how to turn it on. And actually, this is okay. I think this is a interface because normally the MCU cannot understand RS-245. We need put some external devices to make a communication. And if we want to use a computer control the Modbus device, we have to use such kind of USB converter to convert the RS-485 to USB. Then I will plug this USB to my computer. And then I will supply this with power. And then the cable. This cable is the Modbus cable. Oh, not very good because yeah. Then I will open the Modbus 4. I think we already sent you the practice. Yeah, maybe I'll introduce first. If we want to connect to a Modbus support device, this is the interface I'm going to show you later. We have to first select the connection type, and also have to select the serial port at computer. Because I'm using computer. Normally we'll bring our laptop to the to the factories. I will connect the device with with USB converter. Then we can debug the whole system or check the configuration of the system via our computer software. And we have to select the baud rate. Baud rate means communication rate. It's also the speed of the rate. And also we have to select database, and also select the priority mode. I don't want to explain this in detail because of time limitation, but with such kind of information, we can connect this. And where we can find such kind of connection information, we can connect it from our user technical manual. And also, normally, the device will provide you, the interface to change the configuration of such device. Then you have the chance to change the configuration, and then you can get the connection information. First, you have to get the communication in the slave address, normally from 1 to 247. It's called slave address. You can set it, but for this device, actually it's a meter. This is the flow meter used. The default is 8. In a lot of cases, default is 1, but depends on which device you're using. This is baud rate. Baud rate means the communication rate. It's from 120 to like 57,000. The higher the value, the higher speed, but in most cases, 9,600 or maybe 90,200 would be enough. And default, most devices will use 9,600 as default baud rate. And also as priority options, we have 3 options: long, odd, and even. Actually, the default is 0. Okay. Then I'm going to start this software. Can you see my interface of software? Interesting. Okay. First, we have connect. Means have to use connect. Then we come to the selection. In most cases, because we connect the device with the serial port, of course, we have some TCP/IP, but it's not very common. Okay, serial port. Then we have different columns from the Windows computer. For this is for me is 0.5. This you have to choose baud rate. Baud rate I mentioned you can get from the device configuration and also it's from the manual. And this I choose 960. Data bytes is 7 or 8 bytes. 8 will be the common thing. Normally they don't have parity. Normally choose none. Stop it could be 1 or 2, depending on configuration. Then if the connection setup is okay, you can start and click OK. Oh, port 6 not available. That means I have to unplug and replug again because the connection is not very good. Okay, it's connected, but it should time out. Why? Because my simulator uses a default like 19,200. Then can see it because this is a simulator. It uses data. It uses data, some random data, because this is the address from 0 to 10 to 9. That means 10 data bytes. Actually, you can, if you know this configuration that I did this kind of format, can do the format here. Then we interpret the data from some, maybe if you follow the format, from some meaningless value here, I can turn it to be a very meaningful value. You have to get this such kind of information. Oh, this is different. I don't know. Oh, maybe different. So because it's simulated, it's more. Depends on how to interpret the data, but at least those two are meaningful. Those two are meaningful. Okay. First one is 0, and right now, can you see the LED? It's red. Then I will see how to functions right single coil. This is the code 5. Right single coil. Slave address is 1. Address actually is 2 because I know it. I know it's simulator. I can see I want to turn it on. I can click send. Can you see that? The LED turns gray. Turns green means it's on. And now I can turn it off. Send. On. Off. Maybe I turn it on. Okay. For display, I can see that you can always see the communications because we are all based on the interface to communicate. I want to log the information. Okay, communication log. And I can use function right single coil. I see slave address 2. I can turn it on. I can turn it off. On, off. Okay, cancel it. Stop the log. Then I'm going to show you the log file, how the data byte has been communicated with the device. Okay, it's here is a message. Is I send the data, maybe zoom it out. Can you see it better? For that, TX means the master send. For the address 1, function code 5, the address is 2 because I know it. And this is means to turn it on. Then the return message is on. Then in turn, LED on this, turn it on. And then I turn them off. Here, I turn them off. This code, I turn them off. Then it's off. For the rest, it's about reading. Reading multi-registers means here is this is the address of this is slave address. Function code 3 means read multiple holding registers. Starting address is 0, and I want to read A means 10, is hex code. Then I got this in total 10 register data. Then this software use their multipliers capacity to interpret logic to get the data. They can use the data, send cloud, and also for us, for this vendor to just do some temperature check. I think this is case 1. Okay, we can use computer software to to debug, also maybe double check the settings of the Modbus device. Then we can use our, you can see, I will use another device. Okay, those two. Okay, this is controller. I think actually this is a very called DTU, data transmission unit. It uses Atensa, and also here is one SIM card. You can use a mobile network to send message out, but for this capacity we don't use it. I will connect it with wait for a moment. Nope. I will connect the cable. Okay. You can see. Maybe. Can you see it? I will turn my. I use Visual Studio to do some coding, so I will show you the terminals, how to communication with the product. Wait for a moment, it takes some time. Arduino client, I just want to open the terminals. No. Okay. What's the problem? Okay, you can see that. This is a controller. This controller in every, let me check how the client, how about the efficiency, the code, the source code. So in every 5 seconds, it will send one request. This is request, read multiple register. Here is the address of the slaves. And this is a function code 3 means read multiple coding registers. This is starting address. And this is numbers. I think it has the same value like communication protocols here. If they have the same operation of the same device, same address, same function, the command should be the same. And here is a return. Here is first is from device 1, function is 3, and returns like 20. Actually, this is hex code. Actually, in decimal code is 20. This is the value, the returns. And then this is value means that status of system on off is 0 means off. The temperature means I know the temperature is 49, and the data 1 to 3 is multiplied differently or correspondingly because this controller knows how to communicate, interpret the data. And here I'm going to push this button. It will control this slave device. You can see if I press, the color of the LED will be changed corresponding. That means this device is controlling this slave address. This controller, this is gateway controller, is controlling this, Modbus device. Can you see the color changes? Can you? Then we can analyze data and also the command. Here is command. 0101 means address of slave. 1 means read single coil. I think maybe here. 1 is 1. 5 is read single coil, and this is address of the coil. And then 000 means turn it off. Then this is code. Then finally here is response. If I want to turn it on, push again. Okay. See, this is address slave. This is the function code, and this is address of the coil, and then FF00 means I want to turn it on. Then the light turns on. So with this, I can control it. See, I can control it, turn it on and off. It's very reliable. You can You can use as any frequency as possible. See? Okay. And this is for their slave address. I can also, if the slave has the same configuration, I can change the slave to another device because, let me see. Okay. I can turn it on, turn it off. It's the same. Then this controller can be connected to the cloud or maybe some other with LCD control. Then you can use this controller to control 1 to 32 devices. Then we reach the capacity to control the physical layer devices. And that's why Modbus is very important. As I mentioned in my introduction, the Modbus is very, very, very simple if you have some background of the language. Okay, and this is my demonstration. I think I'm approaching to the end. Practices, no more, no more. I think that's all. That's all my presentation today. And also, I'm open to the questions from your side.
Are you done with the presentation, Mr. Ugo?
I finished the presentation. Yep.
Okay. Thank you very much, Ugo, for very excellent presentation. So I think you have made lots of effort for this presentation. You brought both hardware and software simultaneously.
Yeah, because I don't think the trainers from other trainings will introduce such kind of in detail, in depth. But that's because I'm programmer, so I would like to share some insights. And it's a little bit difficult for you if you don't have the background of programming, but at least you can get understanding of something behind digital words. That's the real digital words. You can manipulate even the bytes. If you can manipulate the bytes, you can see that from Modbus, you have only 8 bytes. If you can, can manipulate the 8 bytes correctly, then you can touch the physical layer of the digital world. Any questions? Or
maybe I don't have question. If you have question received, then you can respond that. Okay, I think no question, Ugo.
No questions. Okay.
Yeah.
I know that it's a little bit, it's a little bit difficult for the initial stage, but yeah, we have to show some valuable stuff to you.
Yeah. So I think this session was somewhat technical. So there is question we are not getting. Dear participant, if you have any difficulties in getting this presentation, so no need to worry. We'll upload this presentation and this video in our website, where we have already uploaded the reference material. So you can follow up that. So tomorrow is the last day. There will be 2 sessions. Today we cover some communication protocols. So rest we'll cover tomorrow, and there will be another session, that ABB motor efficiency improvement application matching with motor technologies. That will be covered by Mr. Lokesh BM from ABB India. So with that, thank you very much for your patience and having with us. Mr. Ugo, you want to say something? Otherwise, we will wrap up.
I think I have no more to see. I said too much today. I'm tired, so.
So we'll meet tomorrow, the same time.
See you tomorrow.
Okay. Thank you. Bye bye.
Bye bye.